Okay, so we move on to question 4. Okay, so question 4 here has a ladder which is leaning against the wall. Okay, and then we have a man who is trying to climb up this ladder, and the ladder is making an angle theta with respect to the x-axis. Okay, so we want to find how far this man is going to climb up the ladder before the ladder begins to slide. Okay, we are given the coefficient of static friction between the bottom of the ladder and the ground to be 0.45. So now let's see how far this guy is going to climb. We assume he is going in that direction. Okay, so we want to determine this distance. The distance is going to cover just before the friction is overcome. Okay, so at the bottom here, friction is acting towards the left. Okay, and at the top of the ladder, friction is acting towards the right. Okay, so this friction at the bottom and the one at the top are equal, and we want to find the distance covered by this man just before the ladder begins to slide. Excuse me. All right, so let's consider the weight of the ladder to be W1, which is giving us 200 newtons, and also the weight of the man who is climbing up this ladder to be W2, which is giving us 600 newtons. Okay, and then the total weight, which is W, is going to be the combined weight of this man and the weight of the ladder, giving us 800 newtons. Okay, so now we look at this. So the weight of the ladder is going to act along, it's acting downwards, of course, but the center of mass for this is at L/2, the midpoint of the length for this particular ladder. And we know that the ladder is 5 meters, therefore the half length of the ladder will be 2.5 meters, and that is where the weight of the ladder, which is 200 newtons, is going to be acting from. Okay, so the weight is acting downwards and it is perpendicular to half the x distance. So the x distance we are given 3, so it is perpendicular to this particular length. For the weight of 600 newtons, or the weight of the man, he is going to climb up the ladder and cover a distance alpha, okay, making a displacement in the x with a value of x which is unknown at the moment. So we want to find the value of alpha that this man is going to cover as he tries to climb up the ladder, and we can also consider the distance in the x that he has covered as he goes up. All right, so we consider, first of all, we have to find the friction. We know that the coefficient of static friction is given. We know that frictional force equals mu times the normal force, in which case the normal force is simply the weight of the combined weight of the man and the ladder. Okay, that will give us the total friction force. So we have to combine the weights, both that of the man and that of the ladder. Okay, so then we can find our frictional force to be the coefficient multiplied by the total weight, giving us frictional force of 360 newtons. Okay, so now let's consider the torque. The torque for this system, we are saying the sum must equal to 0. Okay, and each force is acting, we have a perpendicular distance. For example, we have in this case the weight. Okay, it's acting downwards and the perpendicular distance is 1.5 meters. and that of 600 newtons has a perpendicular distance of x. Okay, so we say that the torque about a point P is going to be the frictional force acting along a height of 4 meters. If you look at this system here, the frictional force, we are saying it's acting along a height of 4 meters, the perpendicular distance, then plus, okay, so the frictional force times perpendicular distance of 4 meters minus the weight, which is going downwards, times the perpendicular distance of 1.5 minus weight 2, which is 600 newtons, or rather the weight of the man, times the perpendicular distance of x must equal to 0. Okay, so this is the sum of all the torques about the point P, or rather the sum of the vector sum of the torques for this particular system. Okay, therefore we have that 4 times 360, which is the frictional force, will give us 1440 newtons, and we take the rest to the other side and they become positive, which is going to be W1 times 1.5 plus W2 times x. Therefore we get 1, we have 200 times 1.5 is giving us the 300, and we take it to the left, it's going to be subtracted from 1440. Therefore have 1440 minus 300 giving us 600x. Okay, from which we can obtain the value of x as 1440 over 600 giving us 1.9 meters. Okay, so meaning as this man is climbing up the ladder covering a distance of alpha, he is going to cover a distance of x in the x direction. Okay, so now we move on. If we draw it again, this triangle for this man covering a distance of alpha going upwards, he would have covered a distance of 1.9 meters, okay, in the x. So with theta being given, we know that theta equals 53.13 degrees. We can say cos theta therefore equals 1.9 over alpha. Okay, from which we can obtain the value of alpha as 1.9 over cos 53.13. Therefore, we have alpha being equal to 3.16 meters. So this is how far this man will be able to climb up this ladder before it begins to slide. Okay, so the procedure is quite simple. Here, if you check, we have only used one condition of equilibrium, which is simply the vector sum of the torques being equal to 0. Okay, we have just dealt with the second condition of equilibrium for this particular system. Okay, so you can always go back, check the steps. We proceed. Question 5. So question 5 here is saying we have to show that the static friction force between block A and the surface can hold the system in equilibrium for the weight of block A given. Okay, so in other words here, we simply have to show that the tension T1 is less than the friction force. Okay, so the frictional force has to be great enough to hold the system in place. Otherwise, the system would not stay in equilibrium. Okay, so this is our particular system that we have in the question. So key again, we have to show that T1 is less than the frictional force. Okay, so take note of this system. The tension T3 here, this particular one, is equal to the weight. Okay, so that's why we are saying that T3 is equal to W, which is simply 15 newtons. Okay, and also at the point P, which is here the junction, at the point P we have that T2 sine 45 is equal to the weight. Okay, so the vertical component of T2 is also equal to the weight. Therefore, T2 sine 45 is equal to W, which is equal to 15 newtons. Okay, from which we can obtain the value of T2 as 15 over sine 45, and then we're having the value of T2 as 21.2 newtons. Okay, so also take note that T1 from our diagram here, we have T1 acting towards the right, okay, and our friction is acting towards the left. So we are saying T1 from that junction also, it's T1 equals T2 cos 45, meaning the vertical component of T2 is equal to T1. Therefore, we have T1 equals 21.2 cos 45, giving a value of T1 equals 15 newtons. Okay, so now let's consider the friction also. Since we want to show that T1 must be less than the frictional force, we have found T1 to be 15 newtons. Now let us find the value of the friction force. So we know that friction force is given as F equals mu times the normal force, where mu is our coefficient of friction and is given as 0.3. Therefore, we'll have F equals 0.3 times 90 newtons. Okay, so notice the normal force here is going to be the weight of block A. So block A has a weight of 90 newtons. That's why we're saying the normal force in this case is still 90 newtons. So 0.3 times 90 is going to give us a friction force of 27 newtons. So we can clearly see here that the tension T1 was 15 newtons, whereas the frictional force was obtained as 27 newtons. Therefore, it is shown here that frictional force is greater than T1, and therefore it is capable of holding the system in place. Okay, so this one was very simple, but that is how you go about it. You just consider the forces, you consider the junction there, the sum of the forces, and then you also obtain the value of the friction. Okay, so over to question 6.